in a harmonious, in a more standardized way, store our data sets of our experiments and also upload them to the Synoda platform so that these data sets are available for reuse. And I think that's a very important aspect. So a unique experiment is now available for other research groups or for contractors who are making the design or whatever to reuse it again. The other thing is widening access. So I think you sitting here are the best example of that result, widening access not only in the academic world, but also in the world of critical infrastructure owners and industry. Also very important, the involvement of next generation and female researchers. So tomorrow and the day after, we will organize a training workshop for the third time, where we invite young researchers to join and learn basically from the best of physical modeling. So what kind of research infrastructures are we talking about? Centrifuges, 6 centrifuges. I won't go into the details, but so these are all part of Geolab. But we also have other facilities, as you can see here, like the CEDEX track simulator, or in Maribor, the traffic load simulator. And of course, here in Norway, we have testing fields, 5 testing fields with different composition of the subsoil that you can use for your innovation. So basically, you can start at the low TRL level in a small scale test, for example, in the test facility of Maribor University, and you can go to medium scale and to full scale in these test sites in Norway here. So you can cover the whole range of innovation. So this is our activity framework. So that you can see the different activities that we have. So I talked already a little bit about the transnational access. So we have calls for proposals. And yesterday we made a selection again for about 10 to 12 proposals that will be in the next round for performing research in our infrastructure. The other one is joint research. So instead of each for its own, we develop further our research infrastructure as a group. And that's also that's also what we're doing. And of course, the networking activity is very important to reach out to organize these kind of events, etc. So we started the network from the inner circle, the consortium, the members of the consortium, led by the Altaris and universities and research institutes. We already had in the proposal stage already formed a community, which is in the second circle of academics, industry, and critical infrastructure network managers, and we are expanding this in the third circle. And we have now in this workshop over 100 participants that are now also in a part of our network. So I talked already a little bit about innovation. Innovation is very important in Geolab, and basically we have 3 types of innovation that is happening. One is innovation design, which means that we, with our research infrastructure, we validate new numerical models. These new molecules can be applied in engineering design tools, and in such a way contribute to the whole process of designing and maintaining critical infrastructure. The second one is solutions, focused on solutions, so often offered by industry, of course. So if you want to improve resilience, you need solutions, and we can test these solutions in our research infrastructure. And the third one is the innovation of Geolab itself. So we see a lot of other things happening in other fields, for example, 3D printing, fiber optics for telecommunication. So these new developments, as a group, we want to incorporate into Geolab and use it, and that's what we're doing. I show here, for example, a picture of a tool that we developed within Geolab that can simulate an in-flight mud flow. So then there's a sand mixture inside of this apparatus, and with the here you can open it during the flight and introduce a mud flow stream in your centrifuge. What's also ongoing, I think the plans are ready now, but it's maybe good to highlight is the benchmarking, testing, and prediction event, which means that we will do a benchmark test in the majority of our research infrastructure facilities. Also organizing a prediction event, and this will also be available for other parties if they want to join this in the prediction or in the benchmark testing. Okay, now I'm going to introduce the PEPSTER project. This is a project that won in the first and the second round of the Geolab Transnational Access. It's about piled embankments with basal reinforcement. It's an innovative solution for rail and road networks on soft soil, especially where you have the transition zone from a soft soil situation to, for example, a bridge. It's a good example of collaboration between industry and academics, and also this upscaling. So we started with a small scale model in the facilities of Deltares, and then moved to the facility in TU Darmstadt to do the same similar test on a much larger scale. And also we involved in this project new technology, 3D fiber optic measurements. Okay, and yeah, now we're going to show the movie, and that explains even better than I can do.
TU Darmstadt is offering access to its facilities within the framework of Geolab. Today, we will be taking a closer look at the PEPSTER project.
Pile embankments are used in areas with soft or weak soils where it's difficult to build critical infrastructure. They are made of regular grids of piles with an embankment placed on top of it, including reinforcements. This system allows to build roads, railway lines, and other critical infrastructure safely, efficiently, and quickly in soft soil areas. In most cases, geosynthetic reinforcement is used above the piles at the base of the embankment. In this PEPSTER project, we focus on a new variant of such piled embankments, which uses steel as base reinforcement.
We hope to gain some advantages by using steel basal reinforcement because it's stiffer, more robust, it's made of recycled material, and can be recycled itself. Participating in Geolab is a unique opportunity for Keller that gives us access to these research facilities here. We can cooperate with dedicated technicians and researchers here in Darmstadt and at Deltares in the Netherlands. There we already conducted small-scale lab tests that provided us with valuable experience and information for setting up this large-scale system. A 5 by 5 meter embankment is built in our pit with about 3 meters above the pile heads and a total height of about 5.5 meters. The first response of the soft soil below the embankment is simulated by a 70 centimeter thick layer of crushed rubber. A homogeneous and dense embankment is realized by raining the sand on the soft soil. In the second phase, the support of the soft soil between the piles is reduced to zero by lowering the subsurface. The model consists of 16 piles with a steel reinforcement at the pile heads. The settlement of the piles is simulated by springs at the pile base. The performance of the system is assessed by measuring how the load is distributed between the piles and the soft soil. Therefore, load and pressure cells are installed at several locations in the test setup.
SHM System is one of the partners in Epson. They brought in their advanced fiber optic sensors to measure soil deformation in 3D.
Distributed fiber optic sensing is an innovative measurement technology. In Pester test, we will install two different types of sensors that can provide us information about strain and 3D deformation inside the embankment continuously with a special resolution on 10 millimeters.
We will, for the first time, be able to measure the soil arcing in the entire embankment, which is an essential part of the bearing mechanism in the load transfer platform of piles embankments. Transnational access itself gives me the opportunity to work in a great and motivated European team, to get deep insights into the experimental research as another faculty, and to contribute to a unique test.
Okay, so this was the movie. Thank you for your attention, and we'll move to the next one.